Hello everyone, you're welcome to Guide Academy. This is the first lesson in our algebra course and it's just to introduce you to the number system. Within this course, we'll be doing more of lessons, that is lectures, as well as tutorials, solving more problems for you to understand every concept well. So this is an introductory lecture to introduce you to number systems. Now let's get straight to what you have here. So in this lesson, I'll give you the overview of number systems, and after, in our subsequent lessons, we'll be taking each number system into detail so that we talk about it and understand some properties and special usages of these number systems. Generally, numbers are categorized into two broad forms. So if I take number systems, I can branch number systems into two main categories, and I'll have what we call the real number systems, then we have what we call the complex number systems. In this lesson, we are not going to capture complex number systems. Our focus will initially be on real number systems. So in real number systems, it also has different branches, which we'll be looking at in each lecture and the various tutorials will be organizing. So now let's move straight to this overview. So real numbers are just a category of numbers that are real. Yeah, literally, it may sound funny. So when I say numbers are real, these are numbers which we easily use and commonly use and make sense or logical in a way. Whilst complex numbers, they are numbers mostly used in the engineering domain and really not applicable that much in the reality. We don't really use that in the basic communications and also basic transactions we make. Now, real numbers are also branched into two bigger categories. We have what we call the rational numbers and we have what we call the irrational numbers. So these are the two broad categories of real numbers. These categories also branch again to give subcategories. At this point, rational and irrational numbers are just left behind and we move on with the rational numbers. Now, rational numbers are also branched into another subcategory. So under rational numbers, we have what we call integers. So we have integers. So let me clean this branch and now let me proceed with the evolution of numbers. So under rational numbers, we have what we call integers, right? So after integers will also branch into, let's say, whole numbers. Then whole numbers then also branch to give us natural numbers. So these are just the evolution of number systems and the basic number system tree. So I have this diagram here simply talking about everything I've spoken about here. So it's a summary. So now let's have a fair look on this. So within this is just a bigger circle with concentric circles growing inside it. We can see the first and the basic one here, which we call the natural numbers. And natural numbers are denoted with n. So check n. So these are also called counting numbers, literally 1, 2, and 3 to infinity. The natural numbers will then grow to give us whole numbers, where whole numbers will start from 0. So the only difference between the natural numbers and the whole numbers is simply the addition of what? 0. When I add 0 to natural numbers, it gives birth to what? Whole numbers. The next categories of numbers is what we call the integers, represented with letter Z. Take note of that. So integers here will have negative numbers attached to whole numbers. So integers in quotes are simply defined as positive and negative whole numbers. So that is the next step. And right after integers, the numbers also grow again to what we call rational numbers. Now we grow to accommodate fractions. If I have half, quarter, I have 3 out of 5. I have negative 2 over 6 or negative 2 over 9. All these numbers are just the growth of integers. So if I have a fraction p over q, or I can say A over B. When my Q is not 0, then I can categorize that as what we call rational numbers. Some say ratio numbers. So what you have here is ratio numbers. Is also perfectly correct. Now the last part here, which you are considering under real numbers, is the real numbers itself. Okay, so the real numbers just incorporate both irrational and rational numbers in this circle, where we have square root of 2 being irrational and we have pi. You can realize that you cannot express the square root of 2 as a fraction a over b. Because of that, I cannot call that a rational number, but rather irrational number. There is a special number called pi, right? Pi is a popular number and characterized by the fact that it doesn't have a finite output. Okay, its decimal places goes and go and cannot be expressed as a fraction. So in reality, we call it irrational because it doesn't make sense or it's not logical, right? So that gives us the whole picture of real numbers. In our next lesson, I'm going to take you through each of these number system and how it evolved, the special properties it has, and how to use them appropriately. So stay glued to your seat. Don't forget to subscribe to this channel and follow the course from now to as we move to solving more problems for you to understand this course very well. See you then.